Welcome, everybody, to episode 16 of Integrate Live. I'm Jeff, I'm joined by Alan, and we've got our esteemed guest, Alex from Corso, Benson, and Ben from Opto. We've got another awesome program for you today. Benson, would you do us a favor and just give us maybe at the high level of what we're going to see today and why it matters, and we can talk through it a little bit, and we'll jump into the slide deck, and then we'll get going with the build.
Yeah, and I'll cover some of this on the slide deck when we get going here. But yeah, essentially, we're going to talk about energy monitoring today. And we all recognize the importance of monitoring energy for a lot of reasons. And some of those, of course, are cost, but there's other reasons too, which I'll cover. But what we wanted to try to approach today was this notion of energy monitoring tends to be a little bit esoteric. In other words, there's a lot of people that want to do it, but they're not really sure how to get started. And more importantly, I can put an energy monitoring device on some, electrical load, but then what? What do I do with it? And how do I visualize that? And so what we've done is we worked with Corso Systems to put together a package that includes hardware and software all integrated together to quickly get this data up onto a dashboard so we can start doing something meaningful with that data, like reducing costs, like machine efficiency, and perhaps even trying to address regulatory compliance or ESG. More on that in a moment.
And today we're going to really try to play this from a multiple series of roles, right? So today, as we go through this project, Alan's going to kind of play the role of the corporate guy, right? The corporate initiative, the ESG, sustainability goals. Ben, you're the ground floor level. You're our electrician. Alex, it's going to be a stretch, but you have to play integrator today. And Benson, you're really looking at this as maybe more leadership within the four walls of the site, right?
Yeah, to some degree, the role I'll actually play is Ben as electrician, and then me as the industrial automation engineer, the OT guy, that's going to take this data and model it up, and then get it over to Alex, the integrator, who's going to use Ignition software to visualize this data and do something interesting with it.
Before we get started, just say that this is one of those episodes that really strike to the core of what kind of Jeff and I's vision has been about IntegrateLive, right? You pick a solution, trying to solve some type of a technical problem, and then from start to finish, you unbox it, you configure it, you set it up, and then you show it at the end. This is the outcome, and then you tell how much it costs. And this episode for me, I mean, literally anyone can watch this. Doesn't matter what level of technical skill you have. At the end of it, you could call Opto, buy an EMU, have it shipped to you. The moment you get it, you could go back to this video, and in a matter of an hour to an hour and a half, have that thing up and working and functional. And so really to just, I'm very excited about this. So looking forward to it, Ben and Alex.
All right. Well, with that, let's kick off. Oh, here we go. Benson, I'm going to pop over for your screen share. And how's it look?
Perfect. It looks good here.
All right. Well, let's go ahead and kick off, and we'll make Ben a little more apparent. There he is. Perfect. All right. We're ready to go.
Okay, let's get this show on the road. What are we going to cover today? As I mentioned previously, we're going to spend a minute or two talking about why energy monitoring and why does any of this matter. And then I'm actually going to do a live build with Ben, myself, and Alex from Corso. We're actually going to do an out-of-the-box install. So Ben is going to wire up a load. He's going to talk about what that entails. What are some of the steps he took? And then we're going to take what's called a groov RIO EMU. It's a little product here that Opto 22 provides, and it's an energy monitoring unit. And talk a little bit about what an EMU is, and then we're actually going to configure that EMU, again, out of the box, literally commissioning it, getting it set up on the network, getting an account in there, and configuring the parameters of the load. Once that's done, and that'll, of course, include configuring OPC UA on that device, Then we're going to kick it over to Alex, who's going to actually start to pull up an ignition server and start connecting to that EMU through OPC and use some really cool tools that Alex and his team developed that include both perspective templates and a UDT to quickly and effectively dashboard this information. We're going to do this all in less than an hour. So with that, we'll get right on the road here. So why energy monitoring? Why does anybody do this? Well, there's three main principles around energy monitoring the way we see it. And this is, feedback from our customers, plus, some of the things that we've been involved in over the past couple of years working with state governments and so on. So this is a lot of feedback that we've received. The primary reason, of course, is to reduce operational costs. And that, of course, is operational costs at the plant floor for the most part. And that comes in a myriad of different ways that you can reduce costs. The big one, of course, is just reducing your overall consumption, right? So we're all faced with rising energy bills. We get an energy bill from the utility. It typically goes over to accounting, and they pay it and move on. And the costs associated with that bill go right to the bottom line. But the challenge is, certainly accounting doesn't know where that energy is being spent. But it's being spent, and we have to figure out where it is so we can reduce those costs. But there's another element of your energy bill. And just to be clear, we've developed a blog post on our website that actually takes Opto 22s. We're a manufacturer, so we've been in business for 50 years. We manufacture all of this stuff right here in Temecula, California. It's about an hour north of San Diego. And we, went through our bill, and what we found is that one of the biggest components of that bill are what are called demand charges. And demand charges are different than, how much energy you use over time, which is measured in kWh. Demand charge is measured in kW. kW is the amount of energy you're using at any one given time. And a big portion of our bill, anywhere from 30 to 50% of your bill, is on demand, how much energy you're using at some point in time during that billing period. And you can't manage what you can't measure. And so the idea is if we can start collecting some of this information about some of the larger loads within a facility, and we're about 160,000 square foot facility here at Opto, and about 100,000 square feet of that is manufacturing space. So that's what we want to try to understand where some of the energy was going and where the demand charges were coming from. And then there's one other aspect of the bill, not specific to us. Our utility provider is SoCal Edison, Southern California Edison. But some power companies do charge you for what's called a low power factor. That means how efficiently are you using the energy that the utility provides? So those are the big ones. They're reducing the operational costs. And there's some other elements relative to costs where if I understand how much energy I'm using to make, say, a part, I can start associating the cost of producing that part into the bill of materials, cost of goods sold, things like that. The second part of energy monitoring is sometimes I equate this to like your doctor. You go in for a physical and your doctor has a stethoscope. They place that on your heart and they can start to identify, just how well, your health is. And we can do the same with energy monitoring for a piece of equipment. So by understanding how that piece of equipment is using energy, both, volts and amps together, we can start to identify, is that piece of equipment, one, running efficiently, or two, is there some kind of trend we're starting to see where we're getting more power draw and potentially reducing the life of that equipment? The worst thing that any of us can deal with on the plant floor is downtime. So if we can kind of predict where we might be seeing some sort of impending failure due to, a high current draw, for example, this is a way for us to, identify that and take corrective action. So, and then of course, the other element of doing that measurement with current and volts is we can start to identify that low power quality. And that comes into power factor, things like that. We'll talk about more of that as we move on. And finally, and Alan can speak to this as well, is the notion of meeting what are called ESG guidelines or regulatory compliance. ESG, if you have ESG guidelines in your facility or as part of your corporation, that's environmental sustainability and governance. And a lot of companies are doing this today for their own good, or for perhaps they produce equipment for another manufacturer, one of their customers, and they have to provide this kind of information about how they're using power.
Yeah, you think about carbon tax credits, right?
Mm-hmm.
You think about the from a executive leadership standpoint, you're thinking about those things, about accelerated depreciation because you're doing some level of green or energy consumption saving, right? So there's a ton of things that the average person wouldn't think about at the executive level that has a huge impact on the reputation and also the bottom line of the company.
Exactly right. So, and we're also seeing a lot of activity, particularly around public companies, where investors want to know, just how much, what's their sustainability footprint look like. So that's another reason why we might monitor it. And there's plenty of other reasons, but these are the primary ones that we've been hearing from our customers.
So, Benson, I shared the blog post in the chat.
Oh, thanks.
And if I'm hearing you right, this cut home at Opto, right? This is a problem you ran into, and you said, hey, let's reach into our toolbox. How would we solve this problem? And what we're going to see today is representative of that, right? So the project today is actually going to be focused on a piece of equipment inside of Opto's factory.
That's correct. Yep, we're going to, we've been doing this for about 15 years. We started this journey, I think is early 2000s, mid 2000s, where indeed we were, suffering from very large and growing energy bills. So, again, we eat our own dog food around here. So we decided to, develop products that helped us quickly and easily start to monitor energy. And this was with our previous automation system called the SnapPack system. So we had some ways of doing that with that system. And indeed, what we did, what we learned is there was a lot of energy being used that we didn't know about because we weren't measuring it at the time. So once we started measuring, we could take some corrective action. And as a result of that, and we have a case study as well on our website about this initiative, we ended up shaving 30% off of our electrical bill for this manufacturing facility. And today our bill runs anywhere from $40,000 to $50,000 a month. And so if you can save 30%, that comes right off the bottom line. And, we're a small to medium sized manufacturer. Think of the, large manufacturers, what their energy bills are. We're working with one customer. Their bills are, $1 million a month just for power. So, a small percentage of savings there can directly impact the bottom line.
Yeah. Wow.
So that takes us into, the little device that we're going to use to actually monitor a load on, on whatever it is obviously we want to try to find some of the loads within the building that consume the most electricity. And we started off with a number of things: our air handler units, our tool air compressors. Obviously we're manufacturers. We have, tool air going throughout the facility. So those compressors are running, pretty much nonstop during the work shifts. But today what we're going to do is we're going to use one of these devices here to measure another high electrical consumption device. It's called a wave solder machine. And we still do some through hole type manufacturing here. We've been in business for 50 years, as I said, and some of our older products that we still sell today that we developed back in the 70s and 80s still use some of this old technology, and it's a wave solder bed. More on that coming up when Ben starts to talk about how he instrumented this load. But the EMU itself is a device that's designed to connect to these loads using something called CTs, or current transformers. And Ben's going to go into a little bit more about that. And as a result of this connection, or this instrumentation of this load, we're going to get back 64 channels of power and energy usage data. And this is important because power, of course, is real time. That's instantaneous, what we're using right now. But energy is power over time, measured again in kWh. So this little EMU device will actually accumulate that information, so I can see over time how much a load is using. So both of those values are in there. Up to 3-phase, 600 volt category 3 device. And what that means is if you have what are typical in manufacturing facilities, large 3-phase 40-volt loads, you can connect those directly up to this device. You don't need potential transformers or knock down, a high voltage load down to something smaller to be able to read the data. You can land 40-volt 3-phase directly to this device. And the other kind of cool thing is, we thought about when we were putting this thing together, wouldn't it be cool if it had PoE? Because now I can power the device directly over the Ethernet. And that is what we're doing in this case. But it also supports line power, 10 to 32 volts of DC power, and that works as well. But the other key thing is, and this is with all of our Groov products, we did the same thing with the Groov RIO EMU, it has to be secure. If you're going to put a device on the plant floor and you're going to ask IT to give you an IP address to put this on the plant floor, it better be secure. And indeed, this one is. So, with built-in firewalls and account management, certificates, all of that is in this device. And further, it's browser-based. So I can completely manage and configure this device directly from my web browser. I'm going to actually show you how I've done that. And then finally, communications. Now we've got the data. What are we going to do with it? How are we going to share that data with others? So we give you a lot of different options there. Of course, OPC UA, which is what we'll use for this particular demonstration, but also MQTT, both Sparkplug B and MQTT strings. And for those who still love their Modbus, that's also supported as well. And you can do all of these simultaneously. So it doesn't really matter, just giving you a lot of different options there. And then over on to the left of the screen there, you see some other things in there, OpenVPN, CodeSys, Node-RED. All of those are in this device as well. This particular demonstration, we won't be using those. We're going to keep this pretty simple. But just know that there's a lot of other capabilities all in this, again, Linux-based industrial device. This thing's rated, 0 to 70 degrees C. It's got a terrific warranty on it. It's designed to be put right next to a load on the plant floor and perform as effectively as it possibly can. So with that, let's move on. Enough with the sales pitch. This is the project that we're going to do. So we've got a RIO EMU, we've got some CTs, and we have this in-house wave solder machine. You see the image of it there. And that's what we're going to instrument in this IntegrateLive episode. All right, so let's take a look quickly at the architecture. If you've been to some of our IntegrateLives before with Opto, Ignition, and many of the system integrators we worked with, our architectures are generally a lot more complex. But this one's pretty simple. It's really an EMU connected over Ethernet back to Ignition. And in this case, I'll be running Ignition on the PC that I'm actually presenting from right now. So I've just downloaded and installed the Ignition software from Inductive Automation. Super simple, 3-minute install and you're up and running. So this is a fresh installed Ignition, a fresh out of the box EMU. And then, of course, what we want to talk about next is how did we install this EMU? So for that, I'm going to kick it over to Ben.
Yeah, thanks, Benson. What I'd like to do is just briefly talk about the two main connections that are required to measure power, volts and current. Because power, if you remember your early math, power equals volts times I, or current. Volts times amp equals power, and then energy is power over time. So volts is pretty straightforward. You just tap your volts. But current, we have to introduce a thing called a current transformer, or CT. If you look at the picture on the left, you can see a little green wire going through the middle of a donut. And that wire is the load wire. It has a source end and a load end. And then you've got a very, very small electromagnetic field expanding and collapsing as the AC goes through that. That's proportional to the alternating current that the load is drawing. The CT then picks that up, amplifies it, and sends it out those black and white twisted wires. So that's how a CT works. 3 main types. You've got your solid core, looks like a donut, can't eat it. But it's great for new installations where you can run that load source wire straight through, do your termination, the electrical termination, and you're good to go. In the middle, split core, that's what we generally use for existing installations, because as you can see, you can open that thing up, put it around your wire, snap it shut, done, ready to go. Bus bar, very similar, just a different shape. Now you can get split core bus bars and you can get solid core bus bars. So you can pick what you need there. But That's how we pick up the current of the load, whether it's a building, whether it's a sub panel, or whether it's an individual machine. In our case, you're going to need 3 CTs for 3-phase, 2 CT for 2-phase, a single CT for a single phase. So you just pick the rating that you need based on the load. They come from like 5,000, 6,000 amps down to 5 amps. You know, the size, the little 5 amp ones are pretty cute. They're handy for, you know, monitoring a PC or a small load, something like that. So as Benson said, we've got this wave solder machine. I had no idea about this load. You know, what was its power factor? How much was it pulling? How many kilowatt hours does it take to run per day, per shift, per batch of boards? Don't know. It just, you know, wired up, and it basically what happens in the middle picture, we have a vat of molten solder. It takes a little while each morning to heat the vat up. And then once it gets it to the correct temperature for the particular chemistry of the solder, it'll hold that temperature. Then it's got various thermocouples, which sort of takes us to our picture now on the far right. We've got the blue electrical cabinet with 3 big heat sinks, and the heat sinks are not quite, you know, variable frequency heater elements. They're like a TPO, bang on, bang off, temperature controlled TPO, PWM. But each heat sink there for the 3 phases to modulate the power going into the heating elements, the resistive heating elements underneath the core. Very quickly then what happens is our circuit boards are fed up that sloping conveyor. As they come up the conveyor, the bottom of the board where the pin contacts are touches that wave solder, and the flux then draws the solder up onto that, and then they're washed, processed, tested, and go further into the assembly. So that is wave soldering is an incredibly common method for manufacturing electrical subassembly and parts and things like that. So we've got this machine, we've got a couple of these machines in Opto. They run all day during each shift. So that's the machine. That's what I had to monitor. So what I'm actually going to do to help Benson, to help Alex, is I'm going to fill out a worksheet. I've got this this worksheet here that Benson will actually show, but it's great for me because, you know, what I can do is I can just be jotting this down. What sort of load is it? Well, in this case, it's a wave solder machine, but I've also instrumented the air compressor and air handling units here at Opto. Where's the load located? Basically, what we're doing here is building our asset model. So our single source of truth, all the way from me, from reality, from machine, all the way up to Alex is just going to flow through here. So where is the load? Be handy to know. If someone goes looking for it, if they see non-ignition, they're like, well, where is this thing? First floor, second floor, etc. What's the size of the load? You can have a look at the circuit breaker. You can tell a lot from the gauge wire size. You can look at a motor plate, or as I did, I actually put a clamp meter on. And then the other thing that the EMU needs to know to get the measurements really accurate, is it delta, i.e. no neutral, or is it Y, do we have a neutral? So I'm just rattling down my worksheet. This is great. Yeah, I'm just filling all this stuff out, blasting my way through it. And here's the worksheet. So we've got the size of the CT, the primary. That's also very important for Benson and Alex. As I said, you can get them from 5 amp to thousands of amps. So they need to know, and the EMU needs to know, so that it can do the correct calculation. So in this case, I measured the load size at 28 amps. Well, there's no such thing as a 30 amp CT. They sort of come in sort of whole units, so to speak. So the nearest one was 50 amps. So I put a 50 amp CT on to measure my 28 amp load. Now, the CTs basically have 2 types of outputs. The old style have 5 amps. The new style, much safer, much more accurate, much cheaper, is 333 millivolts. So at 50 amps input, I'm going to get 333 millivolts AC output. The other thing that the EMU needs to know, and thus Benson needs to know, the EMU needs to know it, again, to do that math correctly, is what the line voltage is, 120, 220, 480, etc. So I drop that in, it's 220 volt. Again, the EMU needs to know, Benson and Alex need to know, so they can set the template up, single, dual, or 3-phase. Our solder machine is 3-phase, and I just rattle it down. When was it installed? What's the make of the machine? Where is it? What load? It's a Delta. You can see the host name is very handy for Benson, and every RIO EMU also has a serial number on it. If you actually go, yeah, Jeff, if you can highlight Benson very quickly hold up a RIO EMU there. There he goes. And boom, there's the, on the silver sticker.
See if I can get it in
Auto,
focus.
there
There
we
it
go.
is.
Focus snaps in. Just on the left of the silver sticker was the default host name. That's kind of important because when I bolted in the machine, I may not be able to easily see that host name. So it's great if I just jot that down before I put it in. So next slide, Benson. This is what it looks like. Voltage and current tabs. So on the left image, you can see on the left side of the RIO there is the three-phase fuse. So that's what's called our finger safe fuse. You just pop that whole fuse holder down, and that open circuits all three phases, and you can change out the fuses if you need to. They're generally 1 amp because the RIO doesn't draw any current. It's just a couple of milliamps at most to sniff that voltage. So it's just a safety fuse there. Middle image is the CTs, and you'll notice that we've color coded them: red, black, and blue. Very important that you keep the CT phase aligned with the voltage phase. So red to red, black to black, blue to blue. Again, it's because of that whole phase calculation. You want to make sure that your red phase is matching up with your red voltage. So that the RIO EMU can do the math for you. And then there's just an example of me tonging the unit just with the current clamp, and I measured 23, 28, 30, just depending on where the element was at. It even drops down a little lower than that. So I said, all right, 50 amp CT is going to bring us home here. So very straightforward. Now, in this case, I've actually put the RIO in the unit. For the for the air compressors, there was no real cabinet for them, so I couldn't fit the RIO inside a missing cabinet or a non-existing cabinet. So what I did here was put it above the main breaker. I put the CTs in that unit with the breaker. They fit in there quite well. Picked up the voltage taps. In both cases, I just love the fact that we've got PoE. I can just run that Ethernet cable, jack it in, I'm good to go. That's it. I've got power ready to go, and I've got Ethernet. Now, if you don't have PoE, the RIO EMU will take 10 to 32 volts DC. So you can just put a little switch mode somewhere and run 10 to 32 volts, run your Ethernet cable. You can still power it up if you don't have PoE, but Opto is covered in PoE, so I just run that Ethernet cable back, jack it in, boom, I've got power and network. Very quick, very clean. Makes for a happy Ben.
Great. Thanks, Ben. So Ben's got the wave solder line wired up. What's not been done yet is I haven't configured the RIO EMU for the wave solder line. We have for the compressor, and we'll show that at the very end, just pulling in another load. But we're going to focus on the wave solder machine here. So the next thing some of the things I'm going to do very quickly is just an overview. I'm going to connect to the EMU with my web browser. Ben provided me I have the same worksheet here that Ben completed, and I can see there that I have a host name, a default host name. So I'll use that to actually connect to the device. Then I'm going to actually commission this device right out of the box. So I'll set up an administrator account, configure its time zone. I'm going to change the host name to something a little bit easier to remember than the default one that ships from the factory. I'll get a certificate uploaded to it. I'll configure the load parameters, set all the tags that we're pulling in to be public. Again, this device is a zero trust device, so nothing's available until it's configured, including the account and including any of the tags on there. So I'll do that, and then I'll configure the OPCUA server so that when I pass this worksheet over to Alex, he can actually configure ignition to pull this data in. So it's time to build. This is a live build, so we are going to see how this goes. All right. So I'm going to switch my screen right now over to my browser. And so here I am, just a traditional Chrome browser here. I am in an incognito mode right now for the commissioning process. And so all I got to do is Ben's got that on the network now. So I'm going to go HTTPS because everything is HTTPS. And I'll put in the host name. Okay, Ben, you put down 05-93-F5. So I'll enter it and boom, I'm connected, but I'm getting a warning from the browser saying, hey, we're not sure what this server is. There's no certificate in it. And that's true. There's a default certificate in it, but this browser and the system doesn't know that that's a valid server. No problem. We're just going to go through to get through commissioning and make an exception saying, yep, I know this device and I can connect to it. So we come up to the commissioning page and it says, let's get started. So I'll do so. And the very, very first thing that you do with any groov device is you have to create an administrator account. So I'm going to go ahead and do that. I'm going to put in a name and a password and type in the password twice. Now, it's important that you remember this password because once you create it, it's yours and yours alone. There are no backdoors to this system, just same as with all groov devices. There is no default username and passwords on these things. When it comes on the network, this is the first step you have to take. If you forget, you have to reset the device back to defaults, which you can do. So no problem. I've got it memorized, maybe even write it down, and I'm good to go. Let's configure this device. So we come in and very quickly, I'm here into accounts. You can see there in the users there, that's the account I just created. And that is the system-wide administrator account. I can create other accounts if I wish, maybe just to view things and so on. But for right now, that's my admin account. We also support LDAP with this little energy monitoring unit. So if you want to centrally manage who has access to this device, you can work with your IT team and set up LDAP. So now anybody in the building who has the rights can log on. It also means that, if an employee leaves, you can, close their LDAP account and that account doesn't live on the device itself. So the next step I'm going to take is go into system. Because the other thing is when the device is shipped from the factory, it's shipped with the UTC time. That's Universal Time Code, I think. And right now that's set to universal. We want to set this to a time zone that makes sense. This device does have what's called NTP, and that's a network time protocol. So we can keep the time zone set up and make sure that all the data we collect is time-stamped properly for our time zone. So America, Los Angeles, which is close to us, and I've set the zone and I'm all good there. So I'm going to go back to home. Now I'm going to click into security. And a couple of things right here, we see there's a web server certificate and a firewall. And a firewall is pretty important because there's a lot of services that are running on this device. So I can use the firewall to close down any ports that I don't want open for anybody to access. A key one is like Modbus. I may not want Modbus to be open on there. That's simple enough. I can just turn it off, click OK, and save. And now Modbus is closed on this device. It's designed to be open out of the box for this particular purpose, but obviously I have a firewall configuration there. Okay, before I go and make any changes to the web server certificate, I want to take a quick look at network settings. So if I go to network and click on status, I can see all my network status configurations here. And indeed, on the Ethernet port, I am connected over DHCP. So I actually obtained an address, an IP address from the corporate IT system, and it was automatically allocated. And this is great because that means I don't have to call IT and say, hey, I need an IP address for this little device that's going on the plant floor, to which IT typically responds, no way, we're not going to do that. So with DHCP, now we're using the same tools that IT uses for allocating IP addresses. I'm good to go there. The device also supports Wi-Fi with a USB adapter and also VPN, as I briefly mentioned earlier. That's beyond the scope of this particular demonstration, so I'm just going to leave everything like it is. But what I am going to change is this default host name. So I go into configure, and I highlight the host name, and I'm going to call this wave solder line 1. Okay, and I click save. And when I save it, what's going to happen is it's going to restart the network services on this device. So it's breaking everything down, pulling it back up to put it back on the network. But now I'll be able to access this by the new host name, which is easier to remember than the default one. So we're going to give that a second for the application to reload. Now up in my browser bar, I can see it's now wave solder line 1. I'll go ahead and make an exception one more time and log in once again. So here we go. And these are just typical configuration steps for all of our equipment. Oh, did I see? You got to have your username and password correct. There we go. Okay, so now I'm back in. My host name is wave solder line 1, just as I'd hoped. Now I'm going to navigate back to the home page. And one more time, I'm going to go into the web server certificate and go into here, and I can see the certificate's in there, but it is on the old host name. no problem. I can generate a new certificate, download the public key and all that. But the good news is I have a certificate already created for this thing. So I'm just going to upload it. And I'll go into public certificate. And let's go up to a folder I've already created with my certs in it. And I'm going to grab a certificate and its private key and upload. Once again, the certificate gets uploaded. The device will restart. There we go. And I'll come in and now I'm all set. So now I have my wave solder line 1 set up as my DNS and my certificate's good to go. Okay, so that was in incognito mode there. And that was just to go through the commissioning process. I'm going to close that browser out and just open up a regular browser that's not in incognito mode. There we go. And we'll go ahead and type in the new host name, wave solder line 1. And there we go. And now, because I have a valid certificate, I have a secure connection. I'm totally good to go there. Let's go ahead and sign in. And that was the commissioning process. So now we've got the RIO EMU on the system, on the network, fully secure and IT friendly. So they know exactly what the IP address is. They know it has a valid cert. We're good to go. So the next thing is now we've got to configure the load. So I'm going to go into IO here. And if I can click on it, there we go. And I can see I'm already getting data. So it's saying, 26 watts or whatever. But that's not correct because I actually haven't configured the load properly yet. This is just a default configuration. So I come down here into module configuration, and now I'm going to go to the worksheet here. And I'm looking at the worksheet, and Ben says, oh, the line voltage is 220 volt AC, and it's a delta load. So I come into here and I just choose the range that fits this particular load, which happens to be 0 to 260 VRMS delta. Ben also put on his worksheet that this is a 333 millivolt CT. So I'm going to go ahead and set each of those 3 CTs to the 333 volt millivolt CTs. Then the rated current. So Ben also put on his worksheet that the primary current draw on the CTs is 50 amps. So I'm going to put in 50 right here. And then I don't need to put in the rest. If I put in 1, it propagates on its way down. There's some other, more technical and advanced configurations here, but those aren't necessary for our application. So I'm going to click Save. And when I do so, now I'm getting the actual load information. So I can see I'm using about 3.9 there, kW, or 3,900 watts, up to 4,000 now. And I've got my power factor in there. And just in the few clicks there, I'm starting to get some really interesting information. I'm also getting how much energy has been used since I booted this thing up. So you can see already my kWh, which is, of course, is energy over time, is starting to accumulate. So that's all good. I'm really looking good here. Now I'm going to go into my phases, show all my phases, and there they are. So phase A, phase B. Remember when I said 64 channels of data? There they all are. So I'm going to turn these off for a moment because there's one other step I need to do. As I said, the tags that are in the system are not yet publicly available. So I'm going to make those available by clicking on IO services and go to IO batch operations. And here, my operation, I have a lot of different ones here, but I'm just going to configure public access, make sure I can read the values, and I may want to write to it too. And in this case, I may want to write to reset kWh based on shift, based on day, based on billing cycle, whatever. So I want to make it writable. I'll go ahead and execute that. And we're good. That was easy. Okay, now that we've got the system completely configured, the last part for me to do on the EMU is set up OPC UA. Okay, so that's pretty simple. First thing I'm going to do is click on data service. So all of our data services are hidden under this button. I can see the data service is currently disabled. The first thing I need to do is set up the scan devices. What am I looking at for this OPC UA configuration? So I'm going to click on configure. I'm going to scroll down to scan devices, and I can see there that I can just put in some information, but the key piece of information here is the device ID. And this will become, in case of MQTT, it would be part of the topic namespace. In the case of OPC UA, it will become the node ID. And this will become important later as we start to put in the information into the template for ignition. So I'm going to call this wave solder line 1. And what protocols do I want to make this available to? I can be selective here, but it doesn't hurt anything to keep them all on. So I'm going to go ahead and do that and click save. All right, now that I got my scan devices, the last piece is just OPC UA. And this is pretty straightforward. I'll need to know this discovery endpoint right here. So I'm going to actually copy that to my clipboard. And that's how we'll use, that's how Ignition will be able to find this device. Now, for the purposes of this demonstration, there's a lot of security built into it, but I know this network. It's an OT network. It's a trusted network. So I'm going to go ahead and allow anonymous access. But of course, you can set up username and passwords, and I will allow rights. And that's it. I click save. And once I've done that, I'm going to come back to status, and I'm going to enable the data service runtime. Now, when I do so, the data service will start running on the RIO EMU. And this is a full OPC UA server. And in fact, I'm not aware of any other energy monitoring devices on the market today that actually have an OPC UA server built in. This one does. We're setting it up now. So it's cataloging all of those 64 channels of data and making them available to an OPC UA client, which it's probably a good time to let's go start messing around with an OPC UA client. Let me go back to my presentation and configure Ignition. And this is where Alex takes over. So like I said, Ignition is running on my computer. So Alex, you drive, I'll navigate, or actually I'll drive.
Other way around.
Yes, yes.
So for the Ignition side, as Benson already did, he installed Ignition on his machine. If you don't have Ignition currently, you would want to go to inductiveautomation.com and download, and you can run a free trial indefinitely. You just have to reset it every couple hours. And then we will download the RIO EMU resources from the Ignition Exchange. And I'll drop a link to that here in the chat as well. Those are free. Those will always be free. Currently, we develop them for this demo for just OPC UA, but we will, over the next couple months, update those to include MQTT and some more capabilities on the screen for like historical visualization and some analytics and things.
Oh, that's
so you
awesome.
can check back on those over time, and we'll send out posts probably on the Opto 22 website and Corso Systems LinkedIn profiles when those go up.
So if someone in the audience isn't familiar with the Exchange, just quickly, so the Exchange is essentially Ignition projects that individuals from the community have put on there as a free resource. And Alex and the engineers at Corso have done half a dozen of these. In fact, if you go onto the Exchange, follow that link, but after you download this resource, and you'll definitely want this, it's really not, you're going to see how nice it is, but search Corso and you'll see all kinds of different resources. They've dedicated a lot of time to providing that to the community around Ignition. So thanks, guys.
Yep.
Yeah, one more plug for Corso. One of my favorite tools that Corso built out was there's two of them, but I'm not going to talk about the Pi one. But the most current one that I've used is you've built out and did a white paper on how to use Canary as your historian and bring that data back to Spark lines. And so instead of having to keep data in a historian in SQL, now if you have Canary, just use Canary. It's awesome.
Mm-hmm.
Yeah, we have a resource that helps. I believe it helps integrate with the API to Canary to pass data back and forth. And Andrew Geiger on our team developed that. So then next,
was he wearing his hat when he did it?
Engineer hat.
The engineer hat.
I've never seen him without the hat, so he definitely.
I haven't either.
So
he wears an engineer's cap, like from a train.
Yeah.
He's very into trains. So.
Yep. Shout out to Andrew. Hey, Andrew. Hope you're doing well, buddy. Thanks for all your good work.
And then the next portion of the presentation here, we will configure Ignition to communicate with the EMU and pull in these resources. So we'll basically step through creating an OPC client connection, importing the resources for perspective views, importing the UDT so we can get all the tags mapped properly. We'll create an instance for the wave solder line 1 machine, and we'll drag and drop that to create a screen. And then Benson probably will throw in an additional compressor device that we've also got configured already to show how quickly once you've done the work to get all of this set up in Ignition once, how easy it is to replicate for additional loads. So we'll dive in from there.
Great. You ready?
Yep.
I'll drive, you navigate.
Okay.
All right, so let me go back to here and open up a new tab. And Ignition
So we'll first
is...
go and download from the Ignition Exchange.
Okay, that's a good
I
idea.
usually type ignitionexchange.com and then it'll redirect to what the actual URL is, but
Okay, here we are.
ignitionexchange.com works. And then down in the middle above the resources here, you can search Exchange resources. So we'll search RIO or RIO EMU, and those will both pull up a couple of results,
Okay.
including the groov RIO EMU faceplates, which is the resource that we created and released. So Benson will download that. The only note about Exchange resources is when you upload them, they have the project files and any other files that are related in a zip file. You need to first extract that zip file. If you try and import that directly, it won't import to the project. You have to import a zip file within that zip file.
Okay, I've downloaded it. And to save a little time, I did extract that and put it into some folders so they're ready to go.
Okay. So now we'll go to the gateway webpage. This is your Ignition instance. In this case, what's running on Benson's laptop. And we'll log in.
Guys, real quick, just to save you the pain, reset. Once you log in, don't forget to reset.
Yeah.
Expired trial.
Yeah.
Okay.
Yeah, the orange bar is blinking at, is
just want to make sure you saw
very clear. So, but I have to log in first, so I'll go ahead and do that. And when I installed Ignition, again, a 3-minute process, I did have to create a username and password, which I've done, and I'll log in with that now. And now I'll go ahead and reset that trial. So we have 2 hours to get this done.
So now we'll scroll down in the config page to OPC client and then click OPC connections. And that will give us a list of all of our existing OPC connections from Ignition. We'll click create new OPC UA connection. And then we'll step through this wizard. And Benson will paste the endpoint URL that we copied from the RIO EMU earlier and type in the host ID there. And then Ignition, when you hit next, will go and hit that URL.
And I found it.
Has discovered the server, so we'll choose that. Then we'll select the endpoint, which is the only one available here. And then we trust the certificate coming from the email. And let's confirm the settings. And then we'll name that something that makes sense. Wave solder line 1 OPC UA server. And that's how we'll reference it later on when we get to configuring the tags.
And I just copied that to my clipboard. So when we get to the next step, it'll be easier.
And we'll hit create new connection and it'll show up on the list here. And you'll see the status is connecting. And I don't know, it usually takes between 10 and 30 seconds to connect. So we'll wait for that to pop up.
The moment of truth. There it is. Come on, connecting. Okay, while that's connecting, then
Jeff had a question.
There it is.
There we go.
Jeff wanted to know, Ben, when you put a CT on a solder machine, is that considered a flux capacitor?
Sounds like a dad joke.
Pretty good, Jeff. Well done.
Yeah, so now that we're connected, which we see in the status, we'll go through and grab the designer, which if you don't have a designer installed, you would click Get Designer in the web page on the upper right, and then download for your operating system. And then you would install the designer launcher and then add a connection to your gateway within the designer launcher, and then open a designer.
So I've done that already because I do a lot with ignitions. So I already have designer loaded on my computer, and I do indeed have my local PC, Demo Studio Max, localhost 8088. I'll go ahead and open up that designer. Okay. And it's loading up on another screen I have here. So I'll go ahead and put in my username and password for that. And click log in. And we come up with this.
If you had an existing project you wanted to pull this into, you would just open that project. But since we're going from scratch, assuming you have nothing installed so far, we'll create a new project by clicking the New Project button. And we'll give that a name. And then we will, just to make life easy, we'll select a project template that you will get these installed when you install Ignition. If you select Enable Quick Start, it'll give you a bunch of projects that kind of show you how to do some basic things in Ignition. And then if we were to have a database and things, we would set up some of these parameters to connect to that. So we'll just click Create New Project.
Okay, and over again on my other screen, it's loading up now the designer with this brand new project. And in just a sec, we'll see that come up. And there it is. Okay.
So here's the Ignition designer. You'll see in the project browser, we have a perspective item in the tree. That's primarily where we will be working for the visualization portion. Currently, you have all of the items that were pulled in from the project template that we used. If you didn't have a project template, that would be empty, or if you have an existing project, you would see your items there. So the first step is to import the perspective templates and styles. So we'll go to the File menu and select Import, and then we'll navigate to the base where we extracted those files earlier.
Yeah, and that's Corso templates, and in there I've got let's see, there it is, template 2.0 right there.
And that will give you a list of everything we're importing. We have a handful of style classes to make things look how they should, and then a handful of views. And to make your life easy, we put everything into their own folders in this resource, so they won't overwrite anything that you have currently in your project, even if it's named a similar name. So hit import, and that will populate the views that we're using and the style classes. So now you have everything in your project to pull the views in for visualization. And then next we'll import the UDT. That's a separate object within that zip file that you download, currently just for the OPC UA UDT for the RIO. And then we'll add, I think there's half a dozen others available that we've worked through. So we'll go down there, import tags, and then select the UDT. That will create the folder and the UDT configuration. So that's all the tags and everything that's configured for this device. And then next we will go to the tag browser pane, to the tags tab, and we will create an instance of this UDT. Put it inside of a folder so that it's good for navigation and it makes sense as to where it is. And then within that, we'll go to create a new tag, a data type instance, and select our RIO EMU UDT type. And that will populate the tag editor window here with all the info that we can fill out. So in this case, we'll give it a name so we know what we're looking at. And then we will expand the parameters section. And this allows us to fill out a lot of the information from the sheet that Ben had filled out earlier. So the asset description and location, install date, phases, etc. And a lot of this info will populate in the view once we drag it into the screen, like the description and the location and name and things. So that'll make it easy to see what we're looking at.
Yeah, I think Alex, when we were actually putting this IntegrateLive session together, I think you actually sort of, or sorry, it might have been Jeff or Alan. We were brainstorming. Basically, you could actually make my paper form
Yep.
a web form sort of thing or something, wasn't it? Could you just, while Benson's
Yeah.
filling this out?
So the idea is Benson wanted to keep this really simple, so
paper.
we made it pretty basic. But the idea is that we will build out a form so you could have your electrician, assuming you already have ignition set up, you could have your ignition or your electrician, when he installs the device, they could go through and fill all this information out on, say, their phone or a tablet or a PC.
Yeah, tablet actually
floor.
on the plant floor, right?
Yep.
Yeah.
And we could automatically create an instance of the UDT, map all the parameters, and basically get everything up and running without having to open a designer at all.
Yeah,
and we could also build a screen that's dynamic. So in future releases, we'll build some functionality to even further kind of simplify the process, but we wanted to show from scratch how to get everything there. And I think the keynote here is for the OPC connection name parameter, the second from the bottom. That came from the Ignition OPC UA connection that Benson had copied. And then the OPC device ID comes from the OPC UA server in the RIO. So we made that match what was in there as well. So now that we have all of these filled out, we can, go ahead, Benson.
Yeah, only to mention that, this is, you probably heard recently over the past several years of this notion of the UNS, Unified Namespace, and this is, an element of that. We're actually creating an asset. Now we're modeling this machine with all of its data parameters, but giving it a lot of asset information that could be useful to, once we get this done, we maybe want to send it to a data scientist or whatever, rather than just setting up a bunch of process values. We're actually setting up a modeled asset. So we're modeling the wave solder machine with these UDTs, with all of these parameters in there, so it explains what the load is.
Yep. And speaking of UNS, a short plug, we have a unified namespace guide on our website that you can download that kind of goes through everything involved in a unified namespace and how to develop them and integrate them with Ignition and MQTT and various things. So now that we've created the UDT instance for the wave solder line machine, we have all of the data coming in. You can see these values are changing. If we were to pull up the live page for the EMU, they should match up with what we're seeing there. And if you expand the parameters item there, you'll just see what all you entered as well. Populate there in the UDT. So if we were to pull this into a historian or another system, we can pull out all of this information automatically to understand this asset. So now that we have that set up, the final step in this process, we'll create a new view. So that would be a page in perspective that we can look at. In this case, we'll just use the home page view from the project template. And we set up the UDT to be a drop config, so we can drag and drop the UDT instance onto the screen and automatically build the faceplate onto the screen here. So you drag that UDT instance onto an existing view and select the faceplate type that you want to see, and it will populate with this base faceplate, and then we'll resize it to match this format. If you're using flex containers and things, a lot of that would happen automatically for you. But we'll create the size that we want. We'll hit save, and then we can basically go to the tools, launch perspective, launch session, and it will pull up this homepage automatically based on the URL. And there is the perspective view with all of our data coming in from the wave solder line 1 machine. And this is all pre-configured. If you wanted to go through and adjust this view on your own system, you certainly can. It just gives you a baseline template to start from with all the tag mappings and everything. handled for you. And the idea is you would probably take this and extend it to meet your needs a little bit better, but it gives you a place to start from. So that's basically the whole process of getting data into Ignition. Also, if you wanted to add this to your history, you would want to go through the UDT instance or the UDT configuration and set up your tag history and things there. Since we don't know your historical tag provider settings, we didn't populate that to begin with. And then Benson changed the resolution there to see what it looks like on, say, a mobile device. So that would pull up right on a phone and you could scroll through and see all the data.
Yeah,
I think
when
the
Alex
next step
and
would be if we want to, oh, go ahead.
Alex and his team made these perspective templates responsive. So yes, indeed, you can resize these and do whatever you need to do with them.
So I think the next step would be if we want to add a second device on a EMU that's already configured, we can run through that process pretty quickly here and add the compressor to the screen as well.
So here we'll put.
Yeah, so I'll just jump in so Benson can concentrate on his typing. So as you briefly saw in my earlier session, that we've also instrumented our 2 tool air compressors here at Opto. And that's the one where the EMU is a little bit outside the breaker box because the compressors didn't actually have a panel for me to put it into. We've also picked up an analog output, the transducer for the tool air pressure itself. So we can alarm on compressors not running, tool air being low or anything like that. So that's been really helpful. The other thing though that I found very interesting is these compressors are, large rotating induction motors, and the power factor is not great. So we're actually going to look at sizing a capacitor bank to go on these compressors. So Jeff and Alan, maybe one day down the track after we get that in, we may have to do this 2.0 IntegrateLive session, and we can actually show the difference between the compressor with the capacitor bank power factor correction and without. The reason I'm particularly interested in it is because that low power factor is just heat and vibration. And so we're expecting a nice bump in, a drop in vibration, a drop in bearing heat, and improvement in bearing life and things like that once we get this bank in and just help that induction motor run a bit smoother.
So I've come to the point in the UDT where it's asking for the OPC UA connection name. We just did that for the wave solder machine, but we never did it for the compressor. So easy enough to do. I'll come back to the gateway and go to config again. It is asking me to log in again because I timed out, and come down to OPC connections here again. And let's go ahead and create a new OPC connection to the compressor. So this is the same kind of steps we did before. I've done this once before, so thankfully I have something pre-filled in there. And I'll click next, next, trust the certificate, same steps we did for the wave solder, and click finish. We'll give this one name of compressor 1, OPCOA server. I'm going to copy that, create the new OPC connection. And this one, we have a lot of data in there. So it's been, collecting a lot of KWH and KW. So this will take a little longer to connect, but that's okay. I'm going to come back to my designer and paste in that new OPC connection name from Ignition. And there we go. Let me just see if I can click it and paste. There it is. And the device ID from this compressor's, from the RIO EMU's device ID in the OPCOA server was also compressor 1. And click apply. Okay, so this UDT is now completed, and I'll go ahead and click OK. And indeed, there we go. We have the compressor now. We have all its parameters are in there, and we're starting to get data there. If the OPC connection is connected, it takes a little bit. Yeah, it says error configuration, but that'll come in a minute. But we are getting some data back from that now, particularly from the UDT. So the idea is that once that OPC connection, as I said, takes a little longer for the compressor, But now that I've just modeled another, the first steps are usually getting the OPC connections and stuff set up. Once those are done and I've got my tags in here, now I can drag this guy out, RIO EMU faceplate again. We'll go ahead and size this up. So in this case, I'm just going to put in some parameters and resize this guy so he looks good. And once I do that, I will save it. And looks like I'm not getting data yet, but that's all right. It'll come on soon enough. And then I'll go ahead and launch the perspective session again. And in a moment, those data points will start to populate. So what's cool about this, of course, is that once we get that first steps, getting the import all the exchange resources, get the OPC connections set up. Now, as we get more and more loads, air handler units, the other compressors, the other wave solder machines, I can now start building this dashboard of all these components. And as we said before, we're all within a responsive screen, so we can see everything as it starts to come through.
There you go, Ben. So Ben's over on his device. There's the electrician with his data at his fingertips.
So Ben just connected his phone, or just went to the URL for my server here that's in front of me, and he's being able to pull that data in. So
yeah, it's pretty neat being able to be right next to the machine and see what it's, without having to open the cabinet up or anything. I can see exactly what's going on while I'm watching the machine.
Mm-hmm. Where do you go from here? Okay, now you got the data. We saw that here, and I still have a configuration error on my compressor. But once we have the data, what do we do with it? Well, once it's in ignition, I can do anything I want. I can generate reports. I can historize. I can set alarms. So if that demand starts to get over a predefined value, I can alarm and let people know that a given load is over its demand. Or if the current draw is starting to creep up, we can set a limit there and alarm on that, saying, hey, compressor 1 is showing a value that's it's out of normal, so anomaly detection. And then further, I can start using these systems to actually build out applications. And this application that I have on the screen right now is Ignition Cloud Edition. So what we've done is take all the data, and this is on a separate application. We've taken all the data, sent it up to Ignition Cloud Edition that is actually hosted by the state of Indiana as part of their Energy Insights program. And in this way, I can go and start seeing some of that same data coming through the system. So here now I'm looking at compressor 1, the same compressor we just configured for my local instance is also available for me through the cloud, through whatever. So then I can take it further and start, sending it up to AI or ML applications. I can, the sky's the limit. The challenge is getting the load configured, getting it modeled properly at the edge, and then starting to move that data where it needs to go, whether that's MQTT, OPC, Modbus, it doesn't matter. So a little plug for the state of Indiana. If you happen to be on the call and you are, your manufacturing facilities in the state of Indiana, the state will actually pay for you to do this. They'll give you all the EMUs, the epics, the ignition license, the whole 9 yards. So that's pretty cool on the part of the state of Indiana to do something like that. So my compressor wasn't coming through because I mistyped something in my UDT. That's one thing the UDT doesn't do. Capital C, yes.
I see. Lowercase wins every time, Benson. You will come around, and Ignition will follow me.
So Jeff, you want to show my screen? I can just confirm that indeed it's coming in. But yes, that's the one thing that UDT doesn't do currently is correct misspelled. Misspelled.
Just make everything.
We're working on that, though. We're gonna
lowercase.
I'm sure this is gonna cost quite a bit to accomplish what we did today. Probably talking in the tens of thousands of dollars, right?
Yeah, roughly. Just let's get right to it. There's the pricing. So yes, the groov RIO EMU is $995 at list price. And it is in stock, as most of our gear is. So that's pretty cool. Current transformers vary based on the load size. So we've seen them actually even cheaper than $90, but in general, $90 to a couple $100 for your CTs. A bigger one like this one I have here is a 600 amp CT. I think that one is roughly $130. So you just choose the CTs that are sized properly for the load you're trying to measure, and wire them up to the EMU. And of course, with the voltage tap, now you have current and volts, just as been described. The RIO EMU perspective templates and the UDTs are free, courtesy of Corso Systems. So again, a shout out to those guys for doing a great job of putting those templates together along with these UDTs, and those are free. And of course, Inductive Automation's Ignition platform is a free download with 2-hour resettable trial. So it's easy to reset that. So the bottom line is, for the cost of an EMU and some CTs, essentially all the software is for free. So you can actually, test this out and generate an ROI, generate a use case, show that you've solved a problem, perhaps save some money, even potentially had some more information about the health of a piece of critical equipment on your plant floor. You can test all of that out without spending a dime on any software licenses. And then when you're ready, this particular configuration that I just showed you is Ignition, and it's just Ignition Core, which is $1,000, and then this pricing shows with one perspective license. So that cost is $3,875. So from Ignition directly, or through your system integrator. So naturally that number grows as you start to add on more features, the historical, the reporting, the alarm configurations, all the other things that Ignition provides is available to you, and that's all modularly based. So you can start off very small and start adding the modules to that system. And let's just be clear, this is not a bespoke, energy monitoring application. We're using standardized tools here to collect data from the plant floor and get that data where it needs to be, so that you can, if you're on a digital transformation journey, you're trying to create a UNS, or maybe you're just wanting some visualization, some basic SCADA type functionality for energy loads, this is how you can do it. And these same systems can be used to now connect to your PLCs, connect to other devices, connect to more Opto equipment. It really is just a way to get started, and then you can expand from there. So these aren't specific tools to energy monitoring, with the exception of the RIO EMU. But adding up anything else is easy to do.
The concept of, hey, you're publishing it to an MQTT broker, or you're an OPC UA server right now, I can create an event trigger that says when I start a new batch, grab the value. When my batch is complete, grab the energy value. I now know how much energy I've used per batch, which means I can start to understand my cost of goods a little bit better. I can start to understand how much energy it costs me to run these 1,000 units, right? Really, it's just the very first step. And you said it earlier, you can't manage what you don't measure.
Correct.
Well, think about power factor. Think about the heat that's generated and the damage you're doing to your equipment by not knowing what your power factor is doing. And so the reality of just having that information and know, hey, I'm dipping down in the low 80s, even getting into 70, you're taking life out of that equipment. And so again, knowledge is power. And once you have the visibility and the knowledge, you can start to actually put in capacitors, do different things to kind of correct some of that, so that you can get more resiliency, more longevity. You're not going to have those those outages that you may have by not knowing it.
Yeah, you're right on the money. And power factor is important, certainly from that aspect, but power factor also tells you how much energy you're paying for. So the utility has to provide you this energy. Now, how efficiently you use that energy is up to you. So power factor gives you that kind of visibility in how efficiently you're using it. So this isn't perfect math, but essentially if you're getting a power factor of 7 or 70, or however you want to calculate it, it's usually a value of 0 to 1. So it's 70% essentially. That means 30% of your power is essentially being wasted. Now, some loads need that. They need what's called reactive power to actually operate. But indeed, if you can improve your power factor, you're using your energy more efficiently, and therefore you're using the energy that you're paying for again more efficiently.
Benson, somebody that's on this or watching this later on, and they're saying, yes, I want to move forward with a project like this, but they've got some questions. They want to maybe try to figure out how to customize it to their needs. What's the best way for them to reach out to someone at Opto to kind of have that session?
Sure. So there's a lot of resources that are freely available on our website. The first, of course, is probably the most critical, is that of technical documentation. So data sheets, users guides, all of that is available at no charge, no requirement to log in or create an account. All of this is freely available on our website. Those form numbers are usually the easiest way to track down each of these documents. And then we have free training. So from an Opto side, we have what's called Opto U online training, again, free. You can go in there and learn more about, the hardware level of these systems and how to configure them and so on. For example, all those commissioning steps I just went through, they're all documented in the free training. And indeed, Inductive University also offers free training, including information about how we did the UDTs, how we built the drag and drop, or what they call the drop config for dropping your UDT on the canvas. All of that is included, and again, no charge, on Inductive University. And then we also have offer on our website a live chat. And this chat is not manned by chatbots. It's manned by engineers ready to take your questions and hopefully help you solve your problems. So that's generally during working hours. We also have a field office in Germany, so we kind of cover about 16 hours of the day with live chat. So if you have some questions, looking for some links, or you want to talk more about your application, all that's included as well. And then we have Opto partners all over the globe as part of our Opto partner program, of course, of which Corso Systems is one of our Opto partners, and they're also IIoT certified. So we have a link to Corso on our own website. And then, of course, I have Corso's website there listed as well. And they are indeed a premier inductive automation system integrator. So they know this stuff backward and forward. Get you started, start monitoring some loads, and then start expanding your application to do everything you guys need to do.
Awesome. Thank you.